you know you have to go, oh, this is the one you're making a factoring for. And we talked about this yesterday. If you see one of these with an I or a radical, you know it's a conjugate pair. It's a part of a conjugate pair because that's what comes from your quadratic. Now, when you get back here, I say leave it in factored form. Just leave it like this. You don't have to factor. You don't have to distribute everything out. It's a nightmare to do that. I mean, you can if you want to, but just you can leave it like this. So did anybody have a question? You do have to know these formulas. You need to know these. And remember, we always let A equal 1. And I showed you one where A actually wasn't 1, but we started. If it isn't 1, we let it be 1. And then what happens is B or C becomes a fraction when you do the sum and product. And then you're just going to multiply by its denominator and get it out of there. And then you see A is not really 1. But to do this, we have to eliminate one variable. So we eliminate A first. Yes?
So are we just going to have one like that on the class?
You're going to have one that looks just like this.
Like A.
So you're going to have to assume A is 1. But if one of these becomes a fraction, and you put this in, we never see a quadratic left like this, right? So we're going to multiply everything by its denominator. And then this, it will be your final answer.
I thought it was a fraction that the C has to be a fraction too.
Sometimes it is, sometimes it's not. Sometimes you'll see it as a fraction, sometimes it's not. Yes? For this guy, product, just put this in your calculator and multiply it.
And same thing for how you got 13.
These are, yeah, so watch. These are your perfect squares. You multiply the first terms, you multiply the last terms. I squared is -1. So 9 plus 1 gives us 10. So let your calculator do these.
Okay.
In your conjugate pairs, whether they're radicals or they're i's, they disappear. They're going to work itself out. So let your calculator add it, let your calculator multiply it. Makes life easier. There are perfect squares because they're conjugate pairs, so you can do your first and your last. The middle terms cancel out. And then just leave it in factored form. Good? Oh, you got your work right. Yes.
So how do you not like when A isn't 1?
Because when we start this, as soon as you get to this equation, you have 2 variables. You can only solve one equation for one variable, so we have to get rid of one of them. So we say, let A equal 1. Therefore, we know what B is, and we find C. Now, when we do this, this will all fit into our quadratic, except for if one of these came out with a fraction. If it came out with a fraction, then we just multiply by, technically just set it to 0, multiply by the common denominator, and then A is not really 1. But when we do this, we have to say let A equal 1, because we have to eliminate one of those variables. Did we do systems of equations in here yet? No.
No.
Okay. For every variable, you need an equation to solve it. So if it's one variable, one equation, 2 variables, 2 equations, 3 variables, 3 equations. Okay. Sketch the graph and put it in your calc. Make sure you're looking good with this. Now, what I would do too before you try to sketch it on your paper is lay out all the parts. Find the asymptotes. That's what's going to help you figure out where this is. You actually can see, I'm not sure on your calculator how close it gets to your axis, but if this is 1/2, it's got to ride along that 1/2 line. So it is coming up over that x-axis. So make sure your graph kind of shows me that, your sketch. I'm not sure what it looks like on your calculator, how close it gets to this. It probably sits right on this line. So make sure you get your asymptotes in there and you show me where this goes. Intercepts again, 0's of the numerator, that's your x-intercept. If that x-intercept does not coincide with your graph, then something went wrong. Intercepts are a good way to check, where am I going here? Something's in a different direction. We have no y-intercept because we can't divide by 0, and that makes perfect sense. That's my vertical asymptote, and nothing can cross a vertical asymptote, because that's from your denominator. Noah, you had your homework? Good. All right. Questions? Stop me if you have any questions. Okay. Next one. This guy also has a denominator restriction of it can't be 0. There's your asymptote. Your x equals 0, that's your y-axis. Horizontal asymptote, if the numerator is 1 more than the denominator, let's start again. If the numerator is greater than the denominator, we do not have a horizontal asymptote. If it's 1 more than the denominator, we have a slant asymptote. So this guy has no horizontals, but it has a slant. So a slant says, take the zeros of the denominator, set this equal to 0, so it's a 0, and divide it, synthetically divide it. I don't care about my remainder. So notice we get a remainder, right? The remainder comes from this piece over here, doesn't it? What's left when I subtract these guys? So that's why when we work ourselves backwards from a slant, this is important to us, because it made us do something else. That's why on a slant we have to find that remainder. Remember, since you're x2 over x1, you're always going to be 1 more. You're going to have a line. So this is going to be an x plus 3x plus 0, so just 3x. You can even put this in your y2. You can see your slant asymptote. You can put your horizontals and your slant asymptotes in your y's. And it kind of shows you the end behavior.
So just whatever the equation is after
Is your slant asymptote. You say y equals, and that's it. Get rid of your remainder. Now that's why the remainder is important when we work it backwards, to get back to this original thing. Intercepts, you can leave the radicals in your denominator, but don't leave me this, because that can be simplified. And kind of guesstimate it, put it in your calculator. Radical 3 is a little less than 2, so I'm a little less than 2, so figure 1 something, so I'm over that side, close to 2, and then I'm over that side, in the negatives. Close to the negative 2. So do my intercepts make sense? Yes. My y-intercept, well, I realized I had none, and you're right, because we have an asymptote there, a vertical asymptote. Questions? Always start with your domain restrictions, always, because your domain restrictions tells you a lot, and it even helps you with your point of discontinuity, because when you start that in your domain restriction, and then later you eliminate that and you forget about your point of discontinuity, you can go look at your domain and say, why is this point not there? And then investigate it a little bit more.
So this one in the numerator degree is like 1 more than the
There's not a horizontal if you have a slant. The 3 rules, if the numerator is less than the denominator, you get a y equals 0. You get the x-axis. If it's the same, you get a ratio, a y equals something. Like the last one was y equals 1/2. And if it's greater than the denominator, if the numerator is greater than the denominator, there's no horizontal. You have to know those guys. Again, find all asymptotes. Well, I have no domain restrictions here. No domain restrictions. That means this should be kind of a continuous function. There's nothing to break this apart. I may have a horizontal, but that's fine. And we have a horizontal. The numerator is the same as the denominator, so 8 over 1. There's my ratio. Oh, that's the intercept. It's y equals 8. My intercepts show me I have no horizontal problems here. No vertical asymptotes, nothing in my denominator that I can't use. So I'm good there. My x-intercepts, I didn't do my x-intercepts, right? X-intercepts, take the numerator, set it equal to 0. Sometimes I do forget these things. Take the square root. This one, plus or minus, don't forget to separate these. You can't leave it like this, and you can't leave it like this either. This has a radical 4 and a radical 2. That's fine to leave it like that. Make sure you reduce all radicals, reduce all fractions. Kind of like the same as algebra 2. It's kind of unwritten by the time you get algebra 2. Only algebra 2 you did have to rationalize your denominators. Okay.
Those that have a max and min are like those ones on the
This has a min. It has a min right there.
I was looking at
Oh, 11, I'm sorry. Yes. These guys have a max and min because it's turning down, it's turning up. Okay. Now, were you able to see this in your calculator without changing your windows? No, you had to change the window. But what gives this away is your slant. Put your slant asymptote in your Y2. When you get a slant asymptote, you can't put your vertical in, but your slant is going to show you something. Your slant, and then you can kind of visualize this one here. It's either going to come here and here, or here and here. So if you see anything like this, it's got to be up there too. It's got to have the other part to it, and it's got to use that slant asymptote and that vertical asymptote to guide the end behaviors. So it has to be between the two of them. So change your windows and see where that goes. You're going to have to change your windows for your, if you had to find a min. So this would be our relative min. This would be our relative max. This is a nice concave down. This is a nice concave up. If you had to find that, yes.
So with slant asymptotes, we don't worry about remainder.
Nope. In this case, no. When we go backwards, we do worry about the remainders. Would you like any puff jobs?
I've already
Even taken them out. So find your slant, put that in your y equals. That's going to help you out a lot. And your verticals. Everybody good with this? Is this working out a little better? I kind of separated the pieces and didn't throw it to you all at once. There is a question that says find all the asymptotes. No, if it says find the asymptotes, that's all you have to find is the asymptotes.
Do you want to always sketch it or?
I always want to sketch. I think a sketch is helpful because what happens sometimes when I can't figure out where you got your asymptote or where you got a point from, if I see your sketch, I could at least say, or say to you, does it match your sketch? Or I could see, a lot of times I'll say, I'll base your answer on, your sketch. You know, like I'll say, okay, this is not right, but it's okay for your sketch. So if I sketch some kind of a correlation there, I can work with it. So I like the sketch. Because sometimes, if you put it in your calculator wrong or whatever, I don't see it. And everything's wrong. Okay, so this is a big one. So find the domain, all asymptotes, and the point of discontinuity. Now, make sure you label your point of discontinuity. Like a little open circle, put a letter there, whatever you like to do to it. First thing we do is we factor. So factor everything. Second thing we do, find your domain restrictions. Take out everything. X can't be 3/2, x can't be -1. So go to the -1, jump over it, go to the 3/2, jump over it, and go on. This is important. This is going to help you because when I get to this part, if I forget my point of discontinuity, I only have one domain restriction. It's right here. Where did my other domain restriction come from? It looks like I'm using x equals -1, doesn't it? So, but that tells me, well, what happened here? Oh, this was a point of discontinuity. So it kind of helps you see that. Yes.
If you have the range for this one, put it on 0.
Oh, so I didn't do the range here. So if we ask for the range, so how would I get the range now? Where's your point of discontinuity? -1, 0. So your range is coming up like this. It's coming from -infinity to where? 0. It's going over the 0, and then where else does it have to jump? The 1/2, because there's an asymptote. And then from 1/2 to infinity. Yes.
Instead of like 2x minus 3, is it alright if I put like the 2 outside of the parentheses and then like x minus 1.5?
Don't use 1.5. Use 3/2 if you have to do that. Don't use decimals in there though. Keep it as fractions. Why would you do that? Why would you fract that?
When I said 2L, x squared minus 4
So you left this down here as 2x minus technically 3/2. Is that what you're saying? Okay. I mean, you can. You still got your x's 3/2 in here, so that's fine. It still works. Okay. Just leave it as a fraction. Okay, point of discontinuity, don't forget. You need to reduce this. So when I ask you for your new function, make sure you give me your reduced one. Here it is. Make sure when you give me functions that they have equal signs. Y equals f of x equals g of x equals whatever you want to call it, it's got to have an equal sign. It still is a function. You plug your point of discontinuity into this guy. If you plugged it into this one, it's not going to work. And again, when you graph this, an easy way to tell that it's there is approach this point. Remember our calculus terms, we're going to approach that point. If we approach -1, so say we do -9.9999999, or if we do -1.000001, we should approach that 0. And sometimes you calculated, did you get any of those E things on your 0? The E with the negative something, don't forget those are still zeros. The E, that's a scientific notation. Your calculators do weird things. On this, no. Because this keeps going down like this, approaching this. It keeps going down, and this keeps increasing up here. So there's no maximum here, and there's no maximum here. If it were to jump, if it jumped over like this, and then came back down to guide its end, it would have a max. It would have a max there. Right? Because if you go over something and then come back down, right? Or the same thing here, if it went under this and came back up, it would have a min. Well, the point of discontinuity probably wouldn't be over here. It probably wouldn't jump it and have it right there at the same point. It would probably be out there somewhere else. And that, remember, the times that it jumps over, you really have to be quick to look at that because your calculator is very misleading on those.
Yes, do you just like scroll through your table?
I would look at the table because when your calculator ends, there's something else going on. Either that or set your window. Just go to your window and go Y from -1 to +1. So that your window is like this and you can see what's happening right at the x-axis. That's what I usually do. I just go from -1 to +1 and then your whole screen is just that piece right there. And you can see it a little bit better. Because your calculators do a really bad injustice to that. Because they can't get any more exact than that. Your calculator kind of looks like this. If it jumps over, it'll go like this. So say this is an asymptote right here. Your calculator will look like this. And it will kind of stop there. But usually you can either look at your table or just make this window right here. Set your Y min equal to -1 and set your Y max equal to 1. So that you're just looking right in here and then you're going to see this. You're going to see it cross over. Or when you do your intercepts, you're going to see this has an intercept. Right? If you do your x-intercept and your y-intercept, you're going to see it has an intercept. If it has an intercept, that means it had to touch it, so it had to go through it. It's an asymptote, so it has to come back up to behave, so the ends behave nicely. Remember, your asymptotes are there to guide your end behaviors, so they kind of have to ride alongside those asymptotes. If it jumps over it, it still has to come back up to that asymptote. And yes, you might see one of those. Finding the equation. I don't know what happens to my printing in this one. Okay. Anybody come up with this? Okay. Yes. Okay. So you get the remainder. Okay. So now, when you come back up here, just take your remainder, come back right up to this statement right here, and start like this. Where's your R? It came from this guy right up here, right? So just come right back there and plug it back in. You know what this is like? Y equals mx plus b. Do you guys know your point slope formulas? You know point slope when they give you a point and they give you a slope? How many of you actually use point slope? Okay, what else would you use if you don't use point slope? Oh, just for a line. So say I give you a point. So think back to like algebra. So say I give you this point and I give you this slope. How do you find the equation of a line? Oh, so if I use y equals mx plus b, and I plug this in here, I say 3 is equal to 5 times 1 plus b. Don't I have to find b and then put it back into my equation, right? So it's the same kind of thing here. You have to find r and then put it back into your equation. Same thing you do with the equation of a line. You find a variable and you plug it back in. So once you find it, you have to put it back in. And we know that we can't leave an equation that looks like this. So where is it? So it's up here. So we're over here. We plug in this of 18. We put this over 1, and we just have to find the common denominator. So this needs an x minus 4 to have a denominator. So we multiply it by x minus 4. This has an x minus 4. Just add 18. Now, Amanda, did you get a negative 28 plus 18?
Yeah, and I just, for some reason,
So it's just a computation. Yeah. 18 from here. We did the slant. Your slant was this. This is the equation we're given, right? Plus r over, do you have this denominator? Who asked this? Emery? You have this denominator. So now, when we get to here, do you have this? Okay, so in order to eliminate these, I use one of my points that I'm given. So I look to see, what point did they give me? They gave me a y-intercept. So where across is my y? This is the point 0, 5 halves. So I use my x of 0, I use my y of 5 halves. And then I can find r.
Multiply -4 to 5 halves and then subtracted.
Oh, okay. So that's where you went wrong. What'd you do with your 7? Afterwards. But if you multiply this by -4 and this by -4, you had to multiply that by -4. Right? If you're going to multiply out a fraction, you have to multiply every term. You can, what I would do first is eliminate the 7 first, and then multiply by -4. But if you do multiply by -4, that 7 has to get multiplied by -4. Then that would work. Yes? Yes. Any other questions? Yeah, I know how to do this. Alright, and the nice part about this one is once you reach this point, you're done. Notice that this does have my x minus 4. If I factored this out, I would find whatever else that was in there. I could graph this. I could put my slant asymptote in my y2. I could see that my y-intercept is really at 5 halves. Put them back in and check it. How many of you actually check this when you're done?
no, but I should.
You should. You should. I tell my grandson that too. He's a junior also. And he never checks anything with his calculator. I'm like, that's what that calculator's there for. Okay. This one? Yes. Yes, we can do this one together. Okay, so I got a vertical asymptote. Where does my vertical asymptote come from? My denominator. That's something I can't get rid of, right? So I take this and I set this equal to 0. Do I see a factor that's written like that? No. So I multiply through by my denominator. So isn't 2x minus 3 still the same as 3 halves, right? 2x minus 3. That's in my denominator.
No, how did you? Sorry.
Okay, so if I gave you an equation and I said, find me the zeros to this. How do you find the zeros to this? How do you find the vertical asymptotes to this? Or your domain restrictions? You set them equal to 0. So then what? You subtract 5 and you divide by 2. That's where your fraction comes from, right? So if I reverse this process, I say add this, so I add it. And do I ever really see this in my quadratic equation, any of my polynomials, any of my functions? So the 2's cancel. Well, yeah, I got to get this fraction out of here. So I multiply everything by 2. Aren't I back to where I started? Right? Okay. My horizontal asymptote says it's a 1/2. So that means that this guy up here has to have an x to the 1, right? First of all. And its coefficient, my board's a little off on this side, has to be a 1 to give me 1/2. That's all I know so far, right? Now, my point of discontinuity. How do I work with my point of discontinuity? Factors that cancel out. So I set this equal to x, and I do this. Oh, sorry, I do this. And I say x plus 1. For some reason, my board is getting worse and worse, so just kind of, sorry, bear with me. And give it an f of x, or something there. Okay, so now, I've got this point. I took care of everything, but the only thing I didn't address is that 0. How do I know it's going to come out exactly to 0? And I got a little problem with that. So I say, well, something is going to make this change. So I just take the x and make it x plus n. Because I have to account for that y value. I accounted for its x value. I accounted for your vertical asymptote. I accounted for your horizontal. But I can't make that one be 0. Maybe accidentally it can be, but not that way. So this is what I'm working with. Go ahead. Because it was a plain old x. So if something could get subtracted from it, n could be negative. I don't know what n is going to be yet. As a multiplier, I wouldn't want to multiply it by n, right? I want to add or subtract. Don't I usually work with factors? So that's where you're getting confused. I usually have factors that help me. When we do a point of discontinuity, think backwards. When we do a point of discontinuity, we take the x value, we factor everything, and we plug it in. So I kind of have to work myself backwards. So I had x times x plus 1 plus n.
Yeah.
Not really, because this is being multiplied, this is being added. I want to group this guy into him.
So you just
I
always
need
add
factors. Yeah, you need factors. Don't constantly work with factors. The first thing you do is factor everything. So maybe think back to that. It has to be a factor. So if you start like this, Amani, then just group that in as a factor, because it's kind of sticking out there by itself. Okay? So the rest okay? We're going to cancel this out and work with this guy. We know one point, which is your point of discontinuity. That's your x, that's your y. So if we plug in an x of 1 and a y of 0, we should be able to find n. Don't forget to go plug it back in. Don't forget to leave this to me. And you don't reduce. When you get here, don't reduce your x plus 1s. Why should I not reduce my x plus 1s? Well, this one is because of this. N was 1. So when we go back to your x plus n, if n is 1, that's my first x plus 1. This guy right here is my point of discontinuity.
Oh,
So why should I not reduce this in my final equation? Looks weird. Because why? It would look the same when I graph it, but it would remove my point of discontinuity. And so then it would be a different scenario. I wouldn't have a point of discontinuity. Good.
you can, if you multiply it out,
You could. Absolutely. Absolutely. If you multiply it out, it just leaves a little bit more room for an error. So just make sure you multiply right.
Why would you have this x squared on the side?
Well, this actually is an x squared.
Yeah, because like we did one and it just had a vertical, horizontal, and y-intercept. We started with like 2x squared plus n.
Okay, so is it on this one?
No, it's on like,
It was on the homework? Because what happened is, what did your horizontal asymptote say? 2. So you have to make it a ratio of 2 over 1. So if your bottom had an x squared in it, or your top had it, your bottom had an x squared in it, so we have to have one in your top as well. If the bottom just had an x, we'd only need an x in the numerator. But the bottom had an x squared, so we have to have an x squared. Those have to be the same.
oh, because they gave us 2 vertical lines.
Because they gave you 2 verticals, that was your x squared. Yeah. So it's making sense? Starting to make sense? Any questions? Yes.
How come in number 13 you didn't, like, we distributed the factors out, but then in 14 we didn't?
Okay, how come in number 13?
For
Oh, because that was your slant asymptote. This one you had to, because you have this over here. This is not all factors. Isn't this a term sticking out here? We can leave all factors, but we can't leave terms sitting out there. That's why you did that one. And that's a very good point. Why did we have to clear that up? Because we leave everything in factored form. And you can absolutely leave your things in factors. You don't have to multiply them out. Any other questions at all?